Today's video notes are over proving triangles are congruent using hypotenuse leg. So HL stands for hypotenuse leg. So the hypotenuse leg congruence theorem says if two right triangles have a congruent hypotenuse, so we have two congruent triangles with the hypotenuse that's the same, and a congruent pair of legs. So that means either one of the sets around the right angle. Here we have this base right here. So if we have two right triangles with congruent hypotenuses and a congruent pair of legs, then the two triangles are congruent. So notice that this only works for right triangles. So the reason is because we've discussed side-side angle before, and side-side angle doesn't work. So a way to remember it is Holly Lawrence is always right. So HL for hypotenuse leg, and it only works for right triangles. So, why side-side angle doesn't work? So it's not just because of the name. So if we have a triangle and we have an angle and then the two following sides, the angle's not included. So one of the angles that's not given can either be acute or obtuse. So let's look at an example here. So we're going to start with an angle and a side of a given measure. So what I did was I just copied this one so that I would have two of them. So here, the angle measure is the same, the side measure is the same. What we're going to do is we're going to introduce another side, and we're going to copy that side to the other one, but we're going to change the positioning. So these two sides are also congruent. So here we have an angle and two sides, and remember that congruent triangles have all angles and all sides congruent. So if you look here, you can notice that first off, this side, this last side that we didn't have, isn't going to end up congruent because this one is much smaller. Also, the angles. This angle is larger than the top angle over here, and this one becomes obtuse when this is an acute triangle. So it only works if you have a right triangle. This angle right here, in order to make it not become obtuse and acute, has to be a right angle. So if we're looking at this, we're wanting to see if this can help us figure out triangles that are congruent or not. So we can use our previous ones. So far we have discussed side, side, side. We have discussed side, angle, side. We have discussed angle, side, angle, and angle, angle, side. So now we're just introducing this new one. So these four work on any triangles. Our new one, hypotenuse leg, only works on right triangles. So if we're looking, remember we can always look for sides that are shared. So in this first one, notice that we have this side here in the middle that is shared. So it is always going to be congruent to itself. So by the reflexive property, always congruent to itself. Also, we see that this is perpendicular, so this angle will also be a right angle. So we have two right triangles with a hypotenuse that's congruent and a shared leg. So since we have this, it's a right triangle, we can say that this is by hypotenuse leg. So from this picture, we can see that it's going to be hypotenuse leg. On the second one, I see a side that's shared, so this one's going to be congruent to itself. And now if I look at what I have the two legs. So this is still a right angle. Even though we don't have hypotenuse leg, this one we can still prove congruent by a previous theorem. So I have side, angle, side in each triangle. So this one I can prove congruent by side, angle, side. In the next set, I have two sides and a non-included angle. So side, side, angle, and this one follows the same pattern, but side, side, angle is not one of these four that we have up here. In order for this to work, what we would need to know is if these are right triangles. So this one is no, because we don't know if they're right triangles. So if the triangles are right triangles. So remember, hypotenuse leg, Holly Lawrence is always right. You have to have a right triangle. So hypotenuse leg only works for those. That's the only time that side-side angle exists. And we can't call it that because it's for this special type of triangle in which we have a hypotenuse. Remember, the hypotenuse is always across from the right angle. So if we move on to example 2, we're going to have a proof. So here we have two triangles, and we want to see if they are congruent. So we're going to prove that they're congruent. We're going to start with this first thing that was given. So D is the midpoint of CE, first reason given. So from this, we see a midpoint. So a midpoint means that it is the exact center. The two pieces around it will be congruent. So we can say that CD is congruent to DE because of that midpoint. The reason we can say that is because it's the definition of midpoint. So now we're up to one set of sides that are congruent. So if we introduce these next two things together, because they tell us something specific, they tell me specifically about this set of side lengths. So this should have over bars, but we have that BD is congruent to FD. And that is given. The other thing we were given is that BCD and FED are right angles. So now that we have it marked, we can see where we're moving. We have a hypotenuse and a leg in both that are congruent, but we're missing one important part from the congruence theorem, and that's that first little statement, and it said in right triangles. So since we know that there's a right angle in both triangles, now we can say that they're right triangles so that we can use that theorem. So triangle BCD and triangle FED are right triangles, and that is the definition of a right triangle. So any triangle with one right angle is a right triangle. So once I say that they're right triangles, that's when I can use this theorem. So now I can say that these triangles are congruent because of hypotenuse leg. So I wouldn't be able to use that unless they were right triangles.